Now, as we were talking about the position vector, of course, whenever we draw our coordinate axis, which is x, y, and z, and based on that, if we try to position our vector, which is x I cap, y j cap, z k cap, these I cap, j cap, and k cap basically determine the direction in which it is lying. So I cap is for x direction, j cap is for y direction, and z cap is for, sorry, k cap is for z direction. So here you can see, if I am trying to find out position vector of any vector, let's say, so it is going to be from the origin. Its distance is going to be from the origin. So basically, my x I cap, y j cap, z k cap is nothing but x minus 0 I cap plus y minus 0 j cap plus z minus 0 k cap. Now let's say if instead of origin, we had been given a already existing vector point. So it would become AB vector. And since our B vector is coming out to be in the second part, so it would become B minus A. So basically, if I have AB vector, I can write it down as B vector minus A vector. And B vector is nothing but your position vector of B. And A vector is nothing but position vector of A. So as you can see, B vector minus A vector can be written as x2 minus x1 I cap, y2 minus y1 j cap, and z2 minus z1 k cap. Now let's say if I need to find out the magnitude of AB vector, of course it can be written down as root under x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. And this magnitude is basically the distance of this vector from each other. So that is how generally position vectors are written. And also, let's say if you need to find out the unit vector of AB, so it can be written as AB cap. As you can see here, if I need to find out my AB vector, this is basically my unit vector of AB. So if I need to find out my AB cap, I can write it down as AB vector upon AB vector magnitude. Now talking about components of vectors, generally there are two types of different components, one being the scalar component and the other one being the vector component. So in scalar component, we generally represent only the constants or basically the distance from the respective coordinate axis. And for vector, we include the direction as well. So we are talking about AI cap, BJ cap, CK cap. So basically, it would represent the distance as well as the direction in which it is lying. So as you can see, my vector component is nothing but AI cap plus BJ cap plus CK cap. However, my scalar product or my scalar vector is basically A, B, C. Now, sometimes what happens is generally, of course, not all the time you are going to represent your vector in this format AI cap, BJ cap, CK cap. So just to represent it in a more shortcut way, what we directly write it as A vector ABC. So we call this as the coordinates. So we call this as the coordinates of A, and these are basically their coordinates in the coordinate axis that we have, where A represents the one in the direction of I cap, which is my x axis. B represents the one in the direction of j cap, which is my y axis. C represents my direction in the k cap, which is my z axis. So keep this in mind as well. Now talking about magnitude, the magnitude of vector represents its length. So basically its distance from the origin. If I have only a single vector given, a vector as x I cap plus y j cap plus z k cap, its distance from the origin or its magnitude, or also known as the modulus, can be written as root under x square plus y square plus z square. Now let's say if I need to find out my unit vector, my unit vector would simply be a vector by magnitude of a vector, and it can be written as x upon root under x square plus y square plus z square plus y upon root under x square plus y square plus z square j cap plus z upon root under x square plus y square plus z square k cap. Now, one thing that you must understand here is that my unit vector would always have its magnitude as 1. So magnitude of a cap would always be equal to 1. Now, for this case as well, you can see that your magnitude would always be 1. Your LCM is always going to be x square plus y square plus z square root under. And if I try to find out the magnitude of these three basically terms, what am I going to do? I'm going to put entire thing under root, and I would do x square upon root under x square plus y square plus z square whole squared, plus I would have y upon, I would have this term whole squared, plus I would have this term whole squared. So this would basically become x square plus y square plus z square in the numerator, and in the denominator also I would have the same thing. And once cancelled out, I would simply get 1. So basically Whenever I have a unit vector, of course, as its name suggests, I'm going to have my magnitude as 1, and it can be found out as a vector upon a vector's magnitude.